In this video we are going to talk about the definition of derivatives, and we're gonna see the techniques how to do the derivation of different functions and the differentiations of different functions. So let's start. Let f be a function, a continuous function. So the derivation, the derivatives of, or the derivative of f is a point, you may say. It is a difference or the limit of f of x plus a very small x minus f of x over changing x as x goes to, changing x goes to 0. Meaning it is a kind of expression, maybe a constant, or maybe expression, as you just make what a small in changing x small, what would be the result of that small change in x on the function, as you bring the change in x is too small, very small. Let us see this with example. Let's say f of x is 2x minus 1. So what is f of x plus very small x, change in x? So that's gonna be 2 times x plus change in x minus 1. So this is gonna be 2 times x plus 2 times change in x minus 1. What is f of x plus change in x minus f of x? This is gonna be this one, 2x plus 2 times change in x minus 1, minus, this is f of x plus change in x, minus f of x is 2x minus 1. Okay, let's carry out this change. So when you distribute, this is equal to 2x minus 2x plus 2 times change in x minus 1 minus 1 plus 1. So this is going to be how much? 2 times the change in x. Now the derivative of f derivative of x is defined as the limit of f of x plus a small change in x minus f of x divided by change in x as x goes to, change in x goes to 0. Okay, now we did f of x minus f of x plus change in x, small change in x, minus f of x is already done. So this is how much it is, 2x, 2 times change in x. Now what is the limit of f of x minus f of x plus change in x minus f of x over change in x, which is this one? So you do 2 times change in x over change in x now, but the change in x is going to where? 0. So this is equal to the limit of 2 as change in x goes to 0, which is 2. Meaning if f of x is 2x minus 1, so f derivative of x may be denoted like this, or you can say d per dx of f of x. There are different notations. So this is equal to how much? 2. Okay, now let's some more examples. All right, let's do this one. If f of x is x squared plus 7x plus 6, so what is f derivative of x? Okay, there's a technique that we're going to develop later on for a polynomial function, but now let's apply the definition. So f derivative of x is how much? The limit of f of x plus a small change in x minus f of x over change in x, but as the change in x goes to 0. But f of x is equal to x squared plus 7x plus 6. So how much is f of x plus small change in x? This is equal to, insert here, x plus small change in x, the whole square, plus 7 times x plus change in x plus 6. So what is f of x? F of x is, as it is, x squared plus 7x plus 6. So what is f of x plus small change in x minus f of x. Okay, so f of x plus change in x is this one. So x plus change in x squared is x squared plus this times this 2x, 2 times x times change in x plus the change in x squared, then plus 7 times x plus 7 times change in x plus 6 minus, okay, minus f of x means x squared minus 7x plus 6, not minus, this is plus 6. Let's do the difference for this. So we have x squared here and we have minus x squared here, so we're gonna have x squared minus x squared. Here we have 2x change in x, and another one we have 7x here, so we have to collect the like terms together. So here is how much x we have here? 7x plus 7x plus 7x minus 7x, this one, and you have plus 6 here, plus 6, and we have minus 6, this minus 6 here. So then what else? Then we do 2x, then plus 2x change in x plus change in x square. All right, change in x square here plus 7 change in x. So this is cancelled, this cancels that, that cancels that, so we left with 2x change in x plus there is 7 change in x here, 7 change in x here, and what do you have there? The rest plus 2x change in x plus the change in x square. So this is the difference, meaning this is equal to f of x plus small change in x minus f of x. But the definition of a derivative is the limit of f of x plus small change in x minus f of x over the change in x, and the change in x goes to 0. So this is equal to the limit of this thing, the limit of 2x. So there are 2x here, 2x 7, okay, 2x change in x, okay, 2x change in x plus 7 change in x plus change in x squared. So as x goes to, change in x goes to 0. All right, now let's find the limit of this over, over here is a change in x. So this is the same as the limit of you can take 2x and 7x, 2x plus 7x, they have change in x in common, so plus change in x square, then x goes to, change in x goes to 0, the limit of this. So the limit of this as change in x goes to 0 is how much? Is equal to how much? So we have this over change in x, so we are doing the limit of 2x plus change in x. Here we have going to divide this for both, the above terms by this change in x. So you can do the limit of 2x plus 7, 2x plus 7, 2x plus 7 over change in x is here, over change in x as change in x goes to 0 plus the limit of change in x square over change in x as the change in x goes to 0. But this cancels this one. The limit of 2x plus 7 as change in x goes to 0 is how much? And plus the limit of change in x, the limit of change in x, okay, as change in x goes to 0. But this one is 2x plus 7 plus 0, so the derivative of f of x, so if f of x is how much? So if f of x is x squared plus 7x plus c, so f derivative of x is how much? So this is 2x plus 7, so this is is equal to 2x plus 7. That is the derivative of this one. So we can generalize the following. If f of x is equal to sum a x to the power of n, okay, if this is f of x, then you do f derivative of x very simply is as what? A times n, you bring this into here, then x to the power of, you reduce the power by 1. Okay, this is the formula. So if this is f of x, so f derivative of x is how much? A times n times x to the power of minus 1. Example, let's have example. The previous one, f of x, if f of x is x squared plus 6x plus 7, so what do you get? So here the coefficient is 1, so f derivative of x by this formula is how much? So 1 times, this is 2, then 2 becomes the coefficient, and the x to the power of 2 minus 1 plus 6 times, okay, the power of x is here 1 times 1, then times x to the power of 0. So the derivative of a constant is just 0. So x to the power of 0 is how much? Then 0x, x to the power of 0 is just 1. So this gonna give us f derivative of x is equal to how much? So 2x plus 6. Right? If f of x is equal to x cubed, what is f derivative of x? Now pause the video and try it. So very simply, f derivative of x is equal to, so the coefficient is here, you can write this 1 times x to the power of 3. This is equal to 1 times, the n is here, and times x to the power of 3 minus 1. So this is equal to 3x to the power of 2. That's the derivative. The other, if f of x is equal to root x, then what is f derivative of x? Alright, so to write this one in the above form, so f of x is equal to root x is the same as x to the power of 1 over 2. Alright, so f derivative of x is gonna be how much? So you can write this one as 1 times x to the power of 1 over 2. So this is equal to 1 times the coefficient n is 1 over 2. So 1 over 2 times x to the power of 1 over 2 minus 1. So this is equal to 1 over 2, 1 times half is 1 over 2, then x to the power of 1 minus, 1 over 2 minus 1. So this is 1 over 2 minus 2 over 2. So this is negative 1 over 2. So x to the power of negative 1 over 2. This is the expression. Then you can write this one in the other form. So you know a to the power of minus some minus n is the same as 1 over a to the power of positive n. So this is equal to 2 times x to the power of 1 over 2. So this is the same as 2 times 1 over x to the power of 1 over 2. But x to the power of 1 over 2 is root 2. So this is equal to 1 over 2 times. So 1 over, this 2 is for the denominator, 2 times x to the power of 1 over 2 is the same as 1 over 2 root x. That's it. Similarly, we should note the following. If f of x is equal to 1 over x, okay, so immediately we have to note this one, then f derivative of x is equal to ln x. And if f of x is sin x, then what do we have? F derivative of x is cos x, meaning the derivative of sin x is cos x. And if f of x is equal to cos x, okay, this means f derivative of x is negative sin x minus sin x. These are a very important and known derivatives. So we can summarize like this. We have a table of values. So let's say there is a table here. Then please study this table. It's a very important table. All right, now we have f of x in the first. So let's have here, sorry, so we have f of x here, f of x, these are the f of x's, and here are f derivative of x's. So if f is a the power of x raised to n, then f derivative is gonna be a times n times x the power of n minus 1. So if f of x is 1 over x, then f derivative is ln x. If f of x is sine x, and f derivative is cos x, okay? And if f of x is cos x, f derivative of x is minus sine x. Then if f of x is exponential, meaning it is a the power of x, if f of x is a the power of x, then its derivative is itself a the power of x times its natural logarithm, ln of x. And if f of x log x, then x derivative is 1 over x ln x. So these are important derivatives that we should note. This is for polynomial, this is for just a different one. These two are for trigonometry, but this one is for exponential. This the last one is for the others are, there are important rules, okay? If plus g, okay, f is a function and g is a function, so the derivative of this is d per dx of f of x. The derivative of f of x plus g of x, you can say plus or minus, is equal to, so you can use an individual one, the derivative of f of x plus or minus the derivative of g of x, okay? Or f plus g derivative of x is equal to f derivative of x plus g derivative of x. That is the sum rule. And f minus g, okay, f minus g derivative, the whole derivative of x, is equal to f derivative of x minus g derivative of x. But there is a different rule for addition, for multiplication and examples are here for this sum and division. So for example, if f of x is x raised to 5 plus cos x, okay, then you can split this function into two different functions. So you can call this one is h of x and this one is some g of x maybe. So f of x plus g of x is, g of x plus h of x is the sum, this one. So when you find f derivative of x, you do h derivative of x plus g derivative of x, okay? That means, so what is the derivative of this one? So h derivative of x is how much? So 1 times 5x to the power of 5 minus 1. But this is 5x to the power of 4. And what is g derivative of x? Then it is minus sine x. So f of x, you can see from the above the given, what is f of x? F of x is the sum, yes? F of h of x, h of x plus g of x, yeah, that's the sum. So what is f derivative of x? So f derivative of x is h derivative of x plus g derivative of x, okay? So this means, so h derivative of x is how much? It is minus 5 times x to the power of 4, right? The other g of x is plus the negative of sine x, okay? So this is it. So then f derivative of x is equal to how much? Minus 5x raised to 4. Plus, this one is positive, plus minus is here, minus sine x, yeah, minus sine x. or f derivative of x is 5x to the power of 4 minus sine of x. That is the derivative. The other one is if f of x is how much? If f of x is 4x cubed plus 5x squared minus 11x. So we can you can assume this is one function, this is another function, and that one is another function, and that one. But so you just find the derivative of each one. So f derivative of x is equal to, what is the derivative of this one? 4 times x to the power of, please pause the video and try it, okay? So x to the power of 4 times 3 times x to the power of 3 minus 1, that is 2, all right, plus 5 times 2 times x to the power of 2 minus 1, this 2 minus 1, it is 1, so minus 11 times, this is the power is 1 here, 1 times 11, then x to the power of 0, which is a constant. The derivative of a linear is a constant, the derivative of a constant is 0. So x to the power of 0 is 1. So 1 times minus 11 times 1 is just minus 11. So this f derivative of x is gonna give us 12x squared. Okay, 12x squared plus 10x minus 11. This is a derivative. But for product function, it is a bit different. So if you have h times g derivative of x, then what you do is h derivative of x times g of x plus g derivative of x times h of x. This is a bit complex one, and there's a composite, and there is also quotient. So whenever you are required to find the derivative of a product function. So what you do is the derivative of the outer function h of x, all right, times the inner function. Just you can commutate. Multiplication is commutative. So this is how you do it. Let's find. You are given f of x is equal to x times sine x. Okay, so you split this expression into two functions. Okay, so maybe this x is h of x. Let's say h of x is what? X, this one, and g of x is how much? It is sine x. Okay, so f of x is now what? It is h of x times what? Times g of x. Okay, so what is the derivative of this h of x times f of x? So first we have to find the derivative of each one. So h of x is x, h derivative of x is 1, and g of x is how much? It is sine x, yeah, and g derivative of x is what? How much? It is a cos x. Okay, you can refer the table above. So now the f of x is the same function, yes. So h of x times h of x, basically h derivative of x means f derivative of x means h of x times g of x plus g derivative of x times h of x. That's it. Now h derivative of x is how much? It is 1, yes. So 1 times g derivative of x is how much? It is g of x is how much? It is sine x. So sine x plus g derivative of x is cos x times h derivative of g derivative h of x is x. So this is it. So f derivative of x means hg derivative of x. So that is h derivative of x times g of x plus g derivative of x times h of x. That give us h derivative of x is sine x, 1 times sine x, which is sine x, then plus cos x, x cos x, meaning this is the derivative of x sine x. So the derivative of x sine x is sine x plus x cos x. Let f of x is now x squared times cos x. Okay, now we assume this one is h of x, and you can call it, this one is g of x. So the derivative of this x squared is how much? 2 times x, and the derivative of this one is how much? Minus sine x. Okay, now f of x is the product of h of x and g of x. So the f derivative of x is gonna be how much? It's gonna be h derivative of x times g of x plus g derivative of x times h of x. Okay, now this is equal to how much? So h of x derivative is 2x, g of x is cos x, plus g derivative of x is minus sine x, times h of x is x squared. So this means x squared cos x, the derivative of this, the derivative of this one is how much? 2x cos x. So we have here minus, yeah, minus plus times minus, so minus sine x, I'm sorry, minus x squared sine x is better, minus x squared sine x. Okay, so sometimes in exams you may be required to take this x common, so you can say x into 2 cos x minus x sine x is the derivative of, so this x squared times cos x. The other important thing is a quotient derivative of a quotient function. So if you have f of x over g of x, f over g of x, so the derivative of f over g of x, okay, f over g of x is equal to how much? So this f of x over g of x, you can say, or f over g of x is equal to the denominator function g of x times the derivative of the numerator function minus the numerator function f of x times the derivative of the denominator function g of x over the denominator function square g of x square. That's the formula. Using this rule, we can have the derivative of if f of x is tan x. So what is f derivative of x? So we can consider this tan x as a quotient function, because tan x is equal to how much? Sin x over cos x. Okay, now what is the derivative of sin x over cos x? Okay, so you split these two denominator and numerator, so the above one is f of x, and f derivative of x is equal to how much? Cos x, yeah, cos x, and this one, the bottom one, is g of x, then the derivative of g of x is how much? It is minus sin x. Now the formula says, so f over g derivative of x is equal to, so g of x times f derivative of x minus f g derivative, or you switch the g derivative of x times f of x and over the square of g of x square, the square of this one. This is how the quotient rule works. So the sin x over cos x is equal to the derivative of this one is, so the cos x, the downward one, times the derivative of sin x, which is again cos x. Okay, then minus the derivative of this one is how much? Minus sin x, the derivative of cos x, times sin x again, then over what? Over cos x the whole square, cos x square. So you have, this is equal to how much? Cos x times cos x is how much? Cos square x minus, it is plus, yeah, plus how much? Sin square x over cos square x, yeah. But how much is cos square x plus sin square x? From trigonometric identity, this is 1. The square of these two, the sum of the square of these two is 1. So this is equal to how much? 1 over cos square x. Then if f of x is how much? Tan x, then f derivative of x is equal to how much? 1 over cos x and the square. But what is 1 over cos square from trigonometry? That is sec square. I mean sec x, yeah? That's sec x. So the derivative of d per dx of tan x is how much? D per dx of tan x is how much? It is sec square x, because 1 over cos square is, so cos 1 over cos square is sec square. So that is sec square x. The other one is you are given f of x is equal to x squared plus 1 over, so the denominator function is cos x. So this is the function given, and we are required what is f derivative of x is equal to how much. Okay, so we assume this one as a quotient function, yes? So you can call the above one, this one, as h of x, and the downward one, this is, you maybe call it g of x. So we are looking for h over g derivative of x is equal to how much? So the above one is h of x, so cos x g of x, because the formula says g of x times the formula for this says, so g of x times the derivative of the numerator function minus, then you switch the derivative of g of x times the other function over the square of the denominator function, g of x square. All right, this is the formula. Now we have what? X squared plus 1 over cos x. So we are looking for the d per dx of this one. So what is the derivative of this one? What's the derivative of x squared plus 1? So this is only 2x. So what is the derivative of cos x? The derivative of cos x is equal to minus sine x, yeah? So it is minus sine x. Please study the above table. I'm sorry. Study the above table, minus sine x. Now what do we have? What do we have is this one is, so g of x times, meaning cos x times the derivative of the numerator, which is 2x, yeah? So minus the derivative of this one, minus sine x times x squared plus 1, the numerator one. So this is equal to how much? 2x cos x. This minus is what? Minus times minus gonna be plus, yeah? This is a bracket, so plus x squared plus 1 times sine x, yeah? That's the derivative. So it is 2x, this is equal to 2x cos x plus x squared plus 1 times sine x. So this is the derivative of what? The x squared plus 1 over cos x derivative. A quotient function. Okay, you are given f of x is equal to x squared over x plus ln x. So this is again a quotient function. So you can assume x squared as h of x, and x ln x is as g of x. Okay, so what is g derivative of x? What's the derivative of this one? G derivative of x is how much? The derivative of this x, the derivative of x is 1, yes? 1. Because the derivative of a linear is a constant, plus what is the derivative of ln x? All right, so the derivative of ln x is 1 over x. So this is equal to the derivative of the numerator function, 2x, times the denominator as it is, x plus ln x, then minus the derivative of this one, which is 1 plus 1 over x, times the above function, x squared. Okay, so this is the derivative of x squared over x plus ln x is equal to, so 2x into x plus ln x, so minus 1, okay, 1, it's better to write it as x squared minus x squared into 1 plus 1 over x. So this is the derivative of this function. the derivative of this, sorry, the derivative of x squared over, so by product rule we do this like this. So thank you for watching. We will have the chain rule and the